Welcome you all viewers who are viewing this video. Today, I am giving you information in continuation with the engineering curves, which was my previous lecture that I have created for all of you. So, I, Dr. Santosh Sanodiya, professor from SIRT Bhopal, covering this module, MOOC module, as a part 2 of the engineering curve, and the topic which you all going to understand today, that is concerned as an conics. The concerned topic is conics, because in our previous lecture, engineering curves, how engineering curves classification as well as their different types we were discussed, and conics is why important. That is going to be followed in our today's lecture. So very warm welcome to one and all. So everybody can understand that why this conic section is important. So conic section plays a very important role in engineering graphics. The section obtained by intersection of a right circular cone by a plane in different positions relative to the axis of the cone, that all are called the conics. So with the help of this particular segment, means the right circular cone which is going to be cut at a different positions relative to the axis. So the different positions we were discussed in our part 1. So in continuation with the same, in our today's section that is going to be followed here as conics, why this particular conics is going to be play an important role. So the basic things for the conics is what? The conic may be defined as the locus of a point moving in a plane in such a way that the ratio of its distance from a fixed point, the distance from a fixed point called the focus. Yes, everybody can listen this carefully. And a fixed straight line, that is called the directrix and is always constant. So the ratio between distance of the point from focus to the distance of the point from the directrix, that is going to be constant to the eccentricity. Okay. So this ratio will help us to understand that if their value of the ratio that is going to be concerned to the equality of 1 or less than 1 or greater than 1, that gives us to satisfy the equation of ellipse, parabola or hyperbola. So concerned with this particular segment, eccentricity, we all should be able to understand that the ratio of distance of the point from the focus to the distance of the point from the directrix. So here with the help of this particular diagram, everybody can see that the fixed vertical line that is called the directrix and the horizontal line from the point C that is shown here, that is the axis. So here this particular section, distance of the point from the focus, any of the distance like this V point from the focus to the V point from the directrix. So the ratio between these two segments, that is going to be understand carefully here. So the locus of point moving in a plane in such a way that the ratio of its distance from a fixed point, that is focus, to a fixed straight line, that is directrix, that is always constant. So here directrix is what? The fixed straight line that is going to be followed, that is the directrix, where the M and C indication of the demarcation is there. The cursor movement shows the directrix, and the fixed point we are considering on the line of the axis, that is called the focus. So with this, the line passing through focus and perpendicular to directrix, that is called the axis, which is shown here in the red line. Okay. So with the help of this red line, everybody can get this particular line considered here as axis, that is called axis. So the intersection of conic curve with axis, that is called as vertex. So this particular point is concerned as a point. What I told you all that the distance of the point from the focus The distance of this particular point V from the focus to the V from C means directrix. This is concerned with the directrix. Okay. So always we get one of the important parameter with the help of this, the eccentricity E. Small e is going to be represent for the eccentricity. And if it is always less than 1 between their ratio value, if it is, we found that the value always less than 1, so that is going for satisfying the equation of ellipse. And suppose that equal to 1, so this is for the parabola, and greater than 1 for the hyperbola. Again, I am remembering this particular point or repeating this point. If the value eccentricity is going to be identified as a ratio from the ratio, and it found always less than 1, so for ellipse, equal to 1 for parabola and greater than 1 for hyperbola. So the line passing through the focus and perpendicular to the directrix, that is called the axis, and the point at which the conic intersect or cuts the axis, that is known as the vertex. Cuts the axis, that is known as the vertex, that is the point B. Okay. So in the following figure line, this particular part MC is going to be shown here, that is the directrix. Yes. And F is going to be focus. So this particular section gives us understanding about the line of axis and directrix. Now we will move further. As I already given you the instruction that for the eccentricity, here this eccentricity is denoted by small e. The complete pictorial view represents this particular segment of the directrix and axis. So here the distance of point from focus to the distance of a point from directrix. And with the help of this particular fixed point, any of the method which is going to be followed as a general method or principal method of converting any of the position concerned to the eccentricity for engineering curve with the help of conics. So eccentricity is going to be followed here. VF upon VC is going to be here E. Now, moving towards the conics, we had discussed in our previous part 1, that ellipse is the locus of a point which moves in a plane so that the ratio of its distance from a fixed point, that is focus, and a fixed straight line directrix is a constant and always less than 1. So if the value of the eccentricity is going to be found less than 1, so it is going to be concerned to the construction of, helpful for the construction of ellipse. So according to this diagram, the distance between V to F and distance between the C to V. So ratio between these two is going to be obtained here as less than 1. The ratio of this value is less than 1. So according to that particular segment, ellipse is the locus of point which moves in a plane so that the sum of its distance from the fixed points called focal points or foci, we can say that the foci F1 and F2. So this is the part of that foci and is constant, and the sum of this distance is equal to the major axis of the ellipse. Sum of this particular distance is going to be equal to the major axis of the ellipse. So in concern to this particular part, the major axis is going to be considered here for A to B distance. A to B distance, and this is one of the method of construction of ellipse where we can understand that the distance or dimension of the major axis as well as the dimension of the minor axis. This A, B, C and D, these are the end points through which any of the curve pass if their eccentricity is going to be less than 1. So that satisfies the construction of ellipse. That satisfies the construction of ellipse with the help of given construction. Similarly, here according to the numerical value, everyone can understand that the major axis, suppose 100. So major axis is going to be followed here from A to B, and minor axis is going to be followed here C to D, that is 60 millimeter. So here C point to F1, that is 1/2 times of the AB, or that is going to be considered here as that if followed that part, that is A to O. Similarly, major axis with respect to focus, we can consider here minor axis or major axis distance. Major axis is given here 100 millimeters suppose, and the distance between the focus F1 to F2, that is 60 millimeter. So that the C to F1 is going to be followed here as 1 by 2 times of the AB. That is going to be considered the extreme point for the minor axis. So that A to O, C to F1, this distance is going to be same. And it is also 1 by 2 times of A to B, means the major axis. So this is one of the geometric parameters through which any of the engineering material which are required to construct that particular part for the elliptical curve. So this relation is going to be used for the dimensional parameter of the given required data for industrial use or for their production use. So what are the uses of this particular elliptical relation? So the application is going to be followed here with one of the number of examples, that shape of the manhole is going to be followed with the help of elliptical curve. Shape of the tank in a tanker. So tanker is going to be prepared for carrying any of the liquid or any of the fluid particle. So we can simply call it as tanker. The shape of that tank is going to be manufactured by the engineering material, and the shape is followed here as an elliptical. Flanges of the pipe. There are 5 flanges we are using. Flange means that uses for joining or means we can say that fixing that particular 2 different parts with the help of flange, glands and stuffing box. So any of the foundation part of the machine component or their assembly, that is going to be followed with the help of stuffing box as well as their glands. So these are the engineering terminology through which any of the engineering material which require a curved surface with the help of engineering curve as well as their conic applications, that is going to be prepared. So shape used in bridges and arcs, monuments, path of earth around the sun, and shape of trays, etc. So these are the practical live existing examples through which we can understand why this construction of ellipse is going to be important. So with the help of this particular today's topic, you all will be able to understand that the main applications of the ellipse and their basic information concerned to their eccentricity, concerned to their ratio analysis, which satisfies the construction of ellipse. So very patiently you all have listened this today's lecture. So thank you so much. And in our next part, I am going to cover the parabola and hyperbola with the help of same applications.